Hi, and welcome to part 7 of simultaneous equations and quadratics. We're going to be talking in this lesson about how to find what kind of roots a quadratic function is going to have based on a small part of the quadratic formula called the discriminant. Okay, so let's get started. We've learned already, we remember that a quadratic is anything where you have the highest index on x is squared. And we have solved quadratic functions in various different ways. And the portion of the quadratic formula, which is underneath the square root sign, this is the part that shows or discriminates, it's another word for that, what kind of roots a quadratic will have. Sometimes we hear about discrimination in a negative way. It is negative if we make a judgment and then we make a judgment about something like a group of people and we act on it and it's not true. But to discriminate just means to make a judgment. And so in math, when they talk about a discriminant, it's just something that helps to judge or show. All right? So let's not worry about that, but you may know this word in other contexts. So our hope is that in this lesson, after this lesson, we know we can use the discriminant of a quadratic to determine the number of roots that a quadratic equation or inequality will have. We're going to first of all look at what is a discriminant, and then how does it show the nature of the roots, and what will the shape of different quadratic curves be like based on the discriminant. So first of all, a discriminant, as we've said, is a portion of this formula. So we remember this formula as one way to solve a quadratic equation. And we've sung about it. Opposite of b plus or minus the square root b squared minus 4ac divided by 2a. Hopefully you remember that little song. And the part that we're interested in, the discriminant, is the b squared minus 4ac, just that part. All right? And this little part, b squared minus 4ac, tells us a whole bunch of information. So it's very useful. Let's look at 3 different equations here, and let's find the discriminant for each of these. So if we're finding the discriminant, we have to remember that the general form of a quadratic is ax squared b plus bx plus c. So if you're going to find the discriminant, then we want b squared. So in this case, in the first equation, what is b? It's 6, right? So you want 6 squared minus 4a. A is understood to be 1 if you just have x squared, plus 5. So that's where the c is. So 6 squared minus 4 times 1 times 5 is 20. So 36 minus 20 gives us 16. All right, now you try the next one. See if you can find what is b squared minus 4ac for the second equation there. You can pause the video and then try it. Okay, hopefully you got 25. We have b is 7, a is 2, c is 3. Okay, try the last one. Pause the video again. Okay, hopefully you got 129. We have both a and b are 3 here. And don't forget that you take the negative from that c. So that makes it negative 10 multiplied by 3 multiplied by 4. And you end up getting 129 as your answer. Let's continue and try a few more of these. Now you can pause the video and you can see if you can come up with the answers to these. What is a discriminant? Okay, have you done all 3? If you've done all 3, then we're ready to look at the answers. Okay, so for the first one, you should have gotten something like 28 minus 76. And for the last one, 0. So you can see here that there are different situations, different outcomes. Sometimes we get positive discriminants, sometimes we get negative discriminants, and sometimes we can end up getting a 0. You may recall this before when we did equations, when we ended up with these different terms, but let's talk about what does this then show us. So how does this discriminant then show us the nature of the roots? If the discriminant is positive, then the quadratic will have two real distinct roots. Okay, if the b squared minus 4ac is greater than 0. Let's look and see an example of this. We had the equation x squared plus 6x plus 5 equals 0. And we found the discriminant of this one to be 16. So this must mean then that there's two roots for this equation. And if we would factorize the equation, we can find what those two roots are, right? It factorizes into x plus 1, x plus 5. And from that, we can see that there's two values of x. When this equation equals 0, x could be minus 5 or x could be minus 1. Let's try another one. If you had this equation, what would the discriminant be? We would take b squared minus 4ac and we get a positive number. Now this one doesn't factorize easily. So I wanted to show you an example of this is a case where you would solve and get those two roots. We know it has two roots because of the positive discriminant. But where would we get those two roots? We would get it by using the whole quadratic formula. And if you would punch the numbers in, you get, remember it's plus or minus the square root, so you get a positive square root, you get a negative square root, and both of these will lead to a real answer that x could be 1.9 or x could be negative 0.42, rounded to two significant figures. So that is one situation when we have a positive discriminant. Now, we also saw that we could have b squared minus 4ac be negative. And if it is negative, anything under a square root that's negative is undefined. It's not a real number. We'll deal with them a bit later, but at this point, they're not things that you can define. So it's probably not surprising that if you have a negative, there are no real roots. You have to stop and say no real roots. Probably remember doing that last year with quadratics. Here's an example of an equation where the discriminant ends up being negative. And there's no way to solve this equation. It doesn't factorize, it doesn't work in the quadratic formula. So we say it has no roots because we'd end up getting that negative 23 under the square root sign, and that would stop us. We don't know what to do next. The third situation is when b squared minus 4ac is 0. And in that case, a quadratic will have two equal roots. It seems like just one answer, but it's actually repeated. So let's see an example of that. If we have something like x squared plus 2x plus 1, you may recognize this as a perfect square. But when we find the discriminant, we will find that the discriminant equals 0. If we factorized it, we would get two identical factors, x plus 1, x plus 1. So there's two real roots, but they are the same. Okay, so it's a repeated. So x can be equal to minus 1 because of this being a perfect square. So if you have a 0 discriminant, it means you will have one answer to your quadratic. Okay, so we've talked about what's a discriminant, how does it show the nature of the roots, and the shapes of quadratic curves is what we have to think about yet. If you have a positive discriminant and you have two answers, we said x could be -5 or x could be -1. What does this mean as far as the graph? If we had that same equation equal to y and we graphed it, it would look something like this. And then we need to consider where the x-axis and this curve interact. And the curve cuts the x-axis at 2 points, at -5 and -1. So you can see those 2 points there. And that helps us to know what kind of curve it's going to be, what shape it's going to be. You can have a negative equation as long as it has a positive discriminant. It could also have two solutions. This one, -x² plus 3x minus 2. First of all, if you take the negative out and then you factorize it, then you find that x can be 2 or x can be 1. If you take that same equation equal to y and you graph it, you have a frowning curve because of that negative, but you can see it crosses the x-axis at two distinct points, at 1 and at 2. So that is the feature of a positive discriminant. The curve will cut the x-axis at 2 points. Here's the 1, there's the 2. So whenever b² minus 4ac is positive, the quadratic will have two real distinct roots and it will cut the x-axis at 2 points. So then when b² minus 4ac is greater than 0. What is the graph like when it's less than 0? Here's an example in an equation where the discriminant is -76. We did this one earlier. We said it has no roots, but what would it look like if you graphed it? You can still graph it. Now this is a bit of a faint graph here, but if you look at this one, where is the curve? You can see the curve is way up above the x-axis. So the curve is entirely above or below the x-axis if you have a negative discriminant. And that means that the x-axis and the curve don't interact at all. That's why there's no real roots. Let's look at another example. If I have this equation, it also, if I do the discriminant, it comes out as -23. It would have no roots. But if you graph it, you can graph it. It's all below the x-axis. Okay, so if you have a negative discriminant, the curve will be entirely above, or here it's entirely below. To summarize, when b² minus 4ac is negative, the quadratic will have no real roots. It's entirely above or below the x-axis. The final situation is when b² minus 4ac is 0. And we've said a quadratic will have two equal roots, what seems like just one answer. Now, what you've already seen based on that and what you know, I want you to think, pause the video and maybe work in with a partner next to you and say, what do you think this graph will look like if you have a discriminant of 0? Okay, so I want you to find a partner in groups of 2 or 3, and I want you to just discuss with your partner, what do you think the graph will look like? Okay, so you can pause the video, and when your teacher thinks you've talked about it, then you can carry on, okay? Okay, welcome back. I hope you've discussed it, and here is an example to see you can check your hypothesis. If you have a discriminant that is equal to 0, the graph is going to have a unique feature. It's going to be that the curve touches the x-axis at 1 point only. So basically, it's sitting on the x-axis. Here you can see that it is sitting there, and I think it's -1/2, which is the point. Interestingly, we also have another name for this kind of thing. We would say that the x-axis is acting like a tangent to the curve. Okay, it is the tangent. It's touching at only one point. That point, yes, is -1/2, 0. And that is where that repeated root is. So in this case, you would factor out the 4, and then you could solve the perfect square, and then you would find that x is equal to -1/2. And that is that point right there, -1/2. That's the only place it interacts with the x-axis. Here is another example, just to see it in the negative form. Again, if you notice, it only touches the x-axis at one point. That point this time is the point 1, 0. And if we would factorize this, we would end up seeing it's a perfect square. And the perfect square tells us that x is 1. And that is the point that we see the curve touching the x-axis. Again, the x-axis is a tangent to the curve at this point. Sometimes we are told the nature of the roots, and then we have to find another part of the equation. Let's look at an example of this. Jacob says, I'm asked to find the value of k for which x squared minus kx plus 9 equals 0, has 2 equal roots. What do I do? Okay, maybe you have some ideas for him. Well, Aisha had an idea. Aisha says, well, the discriminant needs to equal 0, right? So how can we find this? We can write down, well, b squared minus 4ac has to equal 0. And let's put in the values that we have, even the unknowns. So b in this case is minus k. And the other things are numbers. Now I can solve for k, right? I can solve down and I can find that, well, k must equal 6, because that's the only thing that can give me 36. Sometimes there will be a range of solutions if you have an inequality, or if the question is asked and it wants to know where will this criteria be true. So what are the positive values of p? Here's an example for which x squared plus px plus 9 has 2 distinct roots. What does the discriminant have to be to get 2 distinct roots? Who knows? You can share your idea? Okay, hopefully you know that to get 2 distinct roots, you'd have to have b squared minus 4ac be greater than 0. So let's plug in the values that we have. B is p in this case, a is 1, c is 9. And if that has to be greater than 0, then p has to be greater than 6. Now, if you took the square root of both sides, you would normally say, oh, I have to get positive or negative, but it says it just wants the positive values of p. So that has already limited, the question has limited the answer for us already. The question doesn't ask you to graph it, but let's graph it just to see what's going on here. If you had these values, the values of p for which this has 2 distinct roots, if we graphed various different solutions, so if we graph p as greater than 6, here is x squared plus 6, that's the one that is the number, then I have 7, 8, and 5. Okay, let's see where these graphs land. If it's 6, we can see that it's touching the x-axis. So there aren't 2 distinct roots. Do you see that? So that's why it has to be greater than 6. If it's 7, then there are 2 places it crosses the x-axis. If it's 8, there's 2 places it crosses the x-axis. If it's less than 6, like 5, it's not interacting with the x-axis at all. So that's what it's looking for here in this kind of a question. Let's summarize what we've learned today by looking at this little chart. Now, if you haven't copied something like this down, you might want to copy this information down. If I have one place where the x-axis interacts with the curve, where it's a tangent to the curve, if a is greater than 0, it's going to be a smiling curve. If it's less than 0, it's going to be a frowning curve. The discriminant in this case is going to be equal to 0. Okay, b squared minus 4ac is going to be equal to 0. If, however, I have two x-intercepts, or I want two x-intercepts, smiling curve or frowning curve, then b squared minus 4ac has to be greater than 0. And finally, we learned that if there are no x-intercepts, there's a smiling curve above the x-axis, frowning curve below the x-axis, then the nature of the discriminant is that b squared minus 4ac will be less than 0. Okay, let's just see that in words here. The discriminant, we learned, is the portion of the quadratic formula which is underneath the square root sign. It shows or discriminates what kind of roots the quadratic will have. We learned that if the discriminant is positive, then there are two real solutions to a quadratic, and it will cross the x-axis at 2 points. If the discriminant is negative, there are no real roots, and it will not cross the x-axis. Finally, if the discriminant is 0, there are two equal roots. The curve meets the x-axis at 1 point only, and the x-axis is a tangent to the curve. So again, you can see that here in a visual form, and if you haven't, maybe take time to write that down yet before you finish this lesson. Okay, just draw a little sketch. All right, God bless you and have a great day, and that's the end of this lesson. Take care.